In this video, we are looking at vertical stretching of the cosine graph in relation to the mother graph y equal to cos theta, which is the green graph here and labeled properly. So if I look at the 3 cos theta here, we must notice that the cos theta is the y value or the dependent value, so I'm multiplying all the y values that we achieved with 3. So if we start anywhere, let us start at A, which is 300 minus 360 degrees. If I take the y value, which is 1, and I multiply it by 3, I will get to J. If I go to B, which is 0, and I multiply by 3, I will stay there. If I go to C, which is negative 1, I multiply by 3, I will get negative 3. So we can continue with E to get plus 3, with F to stay at 0, with G to get minus 3, H we stay at 0, at I we multiply by 3 and we get the value of N. So now we have our dots, and now we have to join them with a similar curve to that of cos, but just stretched vertically. On this page, we have now joined the graph, the points that we made on the previous page, and we get this orange graph here. We notice that if I look from J through K to L, and again from L to M to N, I get exactly the same shape and so forth. So in this case, if we measure from 0 to 360 degrees, we find we have the same period again of 360 degrees. And then I just want to note that the general formula for any trig graph, or in this case a cos graph, will be A cos B times theta minus H plus K, and in this case the 3 and the A coincide, so 3 is the coefficient here, and that coincides with the amplitude. The amplitude is 3. If we use our definition of amplitude, we get maximum of 3 minus the minimum divided by 2, and that will give me exactly the same value there. If we move on to the roots, the points B, D, F, H, they are the intercepts of the horizontal axis of this graph, but the roots, they are the solutions of this equation 3 cos theta equal to 0. And we notice that that will have exactly the same solutions as that of cos theta equal to 0. We did the roots of cos theta equal to 0 when we handled the original function, the cos theta. So, but let's look again at this graph. If we look at the orange graph, we notice that the intercepts with the x-axis or the horizontal axis is again here B, D, F, H, etc., to mention a few of them that is labeled. And if we just look at the first positive value here, theta equal to 90 degrees, then we notice that we have to go from there to there. We have to add 180 degrees to get the next one. So we say k times that, where k is an element of z, and previously we wrote it like this, 2k plus 1 times 100 times 90 degrees. Because we take out 90 as a factor, and then we see that at all the odd numbers, so whenever I put a value in here for k, if I put a value for k here, then I'll get an odd number. If k is 0, I get 1, which gives me 90 degrees. If k is 1, I get 3 times 90, which gives me 270 degrees. If k is negative 1, I get to minus 90 degrees. So, and so forth. So the extreme values, they are plus 3 and minus 3, and they occur at J, K, L, M, N, etc. That is where they occur. So the minima we will find, let us start with K. So at K we have negative 180 degrees. And then to get to the next minima, we need to add 360 degrees. So we write our general formula like this. And we again can take out 180 degrees and we can say, okay, this is now 2k minus 1 times 180 degrees k element of z, and I can just as well write it. I could have started at plus 180 degrees, then this will become a plus, and that will become a plus. It will be exactly the same. It gives you the same formula. It just happens at different situations or at different points. So the maxima, if I start at 0, then I will add 360 degrees to that from L to get to N, and that is just plus k times 360 degrees. So our theta here will be 2k times 180 degrees. So at all the odd numbers, I'll get the minimums, and at the even numbers I will get the maximum. So this also for k element of z. Remember, z is the whole numbers. So the next page will give us a summary of what we said here. Is just neatly typed. On this page you will just find a summary of what we've said about vertical stretching. It is important that you realize that it's only the y values influenced by the vertical stretching and no changes to the roots of the function, and you can write down all the formulas. Make sure that you understand how to write down the formulas. There are simpler ways, but the reason why we write this 2k plus 1 like that makes our calculations easier, and it immediately tells us that the roots happens at all the odd numbers times 90 degrees, the maximum at all the even numbers times 180 degrees, and the minima also at all the odd numbers times 180 degrees. So verify that you understand each and every detail on this page without memorizing it. It is important that you understand the concept and not memorize what's on this page. Then we will look at vertical shrinking from here onwards.